Hello everyone, welcome once again to another machine learning related tutorial by Colors Tech. In this part, you will learn about applying random forest algorithm, the random forest classification algorithm on student performance analysis data. This is the data set of student performance analysis. Here we have many different variables and our target variables are grades of the student. So for example, age of a student, gender, mother's education, mother's job, father's education, father's job, reason for joining the school. This is a school, so this is also a categorical value. So in the data set, we have different demographic information related, uh, you know, uh, variables like urban or rural address, family size, parent status, living together or apart, mother's education, father's education, guardian of the student, school extra educational support is given, family support is given or not, they have paid extra paid classes or etc. And in academic information we have absences, number of school absences, and grades of the first, second and final periods. Target variable, the primary target variable is G3, which is the final grade, which can be used for regression predicting, that is numerical grade, or classification, example, pass or fail or grade categories. So application of this data set is analyzing factors that affect academic performance, etc. So you can get the data set from official website of uci.edu, and this particular data set is well suited for regression and classification related supervised machine learning tasks. First thing, we will open Google Colab and we will connect our environment here. So we are going to perform EDA and machine learning implementation on student performance data. So in the data set that we have here, so in the data set, you can see on the basis of different type of features, we have to predict our target value. So first of all, when you are performing, where you have to apply machine learning, first you have to do some exploratory data analysis in order to understand your data, and before that you have to load the necessary libraries. So let's load all the necessary libraries and modules that we will use in this project. So the libraries that we are going to use are pandas for data processing and reading the data, numpy for numerical operations, cbon as SNS for plotting graphs, matplotlib.pyplot splt also for plotting graphs, and from sklearn, that is scikit-learn, we will use model selection, and from model selection train test split. This will help us in creating different samples. For example, here in this particular data set, we have around 650 samples where both input and output are given. So inputs and output are given here, and that's why we are calling it a supervised machine learning data set. So let's say we break these 650 samples into, let's say we break 550 of them for training purpose. For training our model will understand the effect of all these features on our target value. Like if we increase something or decrease something, what will be the effect? And then after understanding that effect, our model will test the same concept on 100 samples that we will use for testing purpose. So in one of our previous videos, you must have seen, or you can go and see, this is student performance analysis dashboard. This is effect of different variables on a student grade, that is grade 3. So you can see average, etc. So you can do the exploratory analysis in something like Power BI also, but this particular chapter is dedicated towards Python. So obviously this part is for data processing and data visualization, and this part is for breaking the dataset into testing and training samples. Then from scikit-learn.ensemble we can import random forest classifier. So in short, random forest classifier is an algorithm which uses multiple decision trees. In decision trees, we have a input, and on the basis of input, multiple outputs can be there. Then on the basis of one of that output, there can be different conditions. And finally, there will be a prediction from one decision tree. So you can select n number of decision trees here. The theory of random forest classifier and the theory of decision tree has been discussed in our previous videos. So if you are interested in that, we will provide a link to theory part so that you can understand what is the theory behind this. Here basically majority voting is done. So we will apply different type of decision trees algorithms here, and on the basis of majority voting we will select a winner, like what will be the grade, right? So first of all, we will run this, and from sklearn.metrics, we will import classification report, confusion matrix, and accuracy score that will help us in evaluating the overall performance of our model. After loading all our necessary libraries, we will simply load the dataset. So you can see from archive ics.uci.edu. So here in the data set, we have two different data sets. Okay, one for mathematics subject and one for Portuguese subject. So this file that we are seeing here is for Portuguese subject, and performance of this different students in different grades for Portuguese subject. Similarly, we have one more file of mathematics. So that is also there. In both files we only have different samples, obviously performance in mathematics and performance in Portuguese, but these two are important files. If you want to learn more about different type of variables like feature here, categorical, gender, student gender, age, student's age from numeric from 15 to 22, address, like it is a urban student or a rural student, so all these values are given like this. Okay, some of them are given in numerical format, some of them are given as a categorical value. For example, if mothers, let's see here, here it says average of G3 by mother's job, right? You can see in those cases where either mother or father of the student are teacher, then their average grade are also high. Their average grade is 13.14, right? And you can see the minimum grade that any student has got is 0, maximum any student has got is 19. So after loading that, read we will use pd.read underscore csv to read the data. Let's see what the issue is. So we can also download the zip file from uci.edu. It will give us student mat.csv and student por portuguese.csv. Now we will upload these two files in our file section here in Google Colab and then read. So we have just selected the file from our local computer, and you can see the files are getting loaded. We will copy the path, and it will be mathematics will be student mat.csv, and Portuguese one will be path. Let's load them and see the effect now. And now let's see the head of mathematics so that we can see all the columns are loaded properly. Here you can see it is not loading because we have to use that, we have to tell the pd.read csv that the delimiter used here is a semicolon. So now after telling, after using the parameter separator is equal to semicolon, now we can see student math.head is loaded properly, and similarly por.head. Let's see. So here somehow this is not loading. Let's see what's the reason is. Now you can see the funny thing is here in Portuguese the separator is actually comma. So you have to see it carefully what type of separator is used in your CSV file. So it is indeed the comma separated value file. So now it is loaded properly. So make sure that whatever file you have downloaded, you can open it in Notepad or Notepad++. For example, this is the CSV file. If you will open it in Notepad, you will see what delimiter is used here. And similarly, you know, use that delimiter. Now we have two data sets. So what we can do using pd.concat, we can join them together. Like we can concatenate them, right, on vertically, because both of them have same uh, columns here, same fields. So we will just concatenate them and create a bigger file. So this file, if you will see students.head, so let's verify that. So this file has 5 rows and 33 columns. So now we have three data frames here, right? One is student Portuguese, one is student math. So if you write student Portuguese dot shape, you will see its entire shape. So it has 649 rows and 33 columns, which you can see here, right? 650 here. And similarly, if you will write mat.shape, so it has 395. And finally, the file that we have, in this file, when you will to shape, it will contain 1044, which is sum of 649 and 395, and columns will be same. So now this is our file that we are going to use to do exploratory analysis and training our model. Now, whenever you are doing exploratory analysis, you can do a quick overview of the data. So obviously data set shape is something that we have already done. You can see all columns. You can see if is null, like how many missing values are there, and you can see the first few rows. So you can see all columns are loaded here, and missing values, we can see we don't have any missing values, and that is clear from the data original data source also. So now we don't have any missing values. Now we can, so students is the data frame. If you will write dot info, so this will give you information about data type of all the columns and how many null or not null values they have, what type of index is used. You can see data type, some of them are integer, some of them are object, that is string. So most of them are either integer or string fields here. You can also write students dot describe. What it will do, it will give you the statistical description of the data. It will select all the numerical columns like age. So on an average, the age of a student in the data set is 16. Mother's education level is 2.6. Father education level is 2.38. So here you can see minimum and maximum value. So minimum value for mother education level and father education level are 0. Maximum you can see 4. So that's why average is 2.6. So you can see on an average we have the average mother education value is 2.6, which is higher than father's education value. Travel time is the time they are taking to travel to school. So this average is study time, the amount of time they are spending for study. Failures, how many failures did they have previously. Family relationship, this is a measure of family relationship value. So this is support, and let me show you family relationship because it was described here. This quality of family relationship, that means 1 very bad relationship, 5 excellent relationship, right? So you can see on an average every student has a family relationship score of 3.9. Free time, how much free time are they spending, right? Free time after school, 1 very low, 5 very high. So the purpose of this analysis will be to see if someone has more free time, are their grades high? If someone has, you know, their family relationship value is good, are their grades high? You can see average of G3 by failures, for example. So people having zero failures have higher average grade than people having failure. You can see people who have failures, three failures, their average grade is also lower. So this type of analysis will be done here, right? So we have all these variables and their meaning. DALC means workday alcohol consumption, numeric from 1 very low to very high. If they are consuming high alcohol, then is it affecting their grades? Weekend alcohol consumption, are if they are, consuming alcohol in on weekends, very high alcohol on weekends, is there affecting their grades? Their health, current health status, if health is very bad to very good, is health score affecting the grade score, right? So this is a great data set to see effect of categorical, discrete, and continuous numerical values on an output. So now we can see the description here, and one by one you can see the averages. So average G1 grade score is 11.2, average G2 is 11.24, average total, which is the final target value, is 11.34, which is, which you can see here also, minimum and maximum. So everything that, for example, in Power BI that we have done like this. So just using students.describe, just using your data frame.describe method will give you the same output here. Now let's visualize some data. So to visualize data, the first graph that we are using is a count plot. So in count plot, as the name suggests, it is used to count something, right? So show the count of observation in each categorical bin using bars. So for example, we are saying data will be the student's data, the data set that we have. On x-axis, we are going to put sex or gender here. And the palette, this is a palette, it's like a color palette. For example, here we have used a color palette. Like if you go to view, you see you have different type of color palettes here, right? So in Seaborn also there are different type of color palettes. So sometimes your bar will look, bar graphs or scatter plots will look darker or lighter. So we are using cool warm. So it gives a cool warm kind of texture to our graphs. So what you do here, in data you put the name of your data frame, which is students. On x-axis you put gender or any other categorical value, and in palette you can select cool warm, and there are different type of palettes that you can use here. And when you will uh, do it, you will see the gender distribution. So gender distribution, you can see we have more female students and less male students. This is the gender distribution in the data set. So we have not selected any other thing, just x is equal to gender and data is equal to students. Next, whenever you have a variable like age, okay, so you can see in age we have minimum and maximum age. So you can see minimum value is 15 and maximum value is around 22, which you can see from your, we don't have to go anywhere else. We can see from our this analysis that average is 16, minimum is 15, maximum is 22. So in that case, if your variable is a continuous numerical value like age, so you can create a histogram plot. So we are using cbond dot hist plot, histogram plot. Data will be student. So this is the first parameter, its value is student. In x, we are going to use age. Kernel density estimation is going to be true. This will provide a smooth curve for our data. So in distribution plot, you usually see bars, right? You usually see bars. Kernel density estimation is a smooth curve represent, and this shows us in which particular age bin the probability of finding values will be more. You will just see that. And the color that we are using is sky blue color, and bins is equal to 10. we are using 10 bins. So we are dividing age into 10 bins. Obviously here the age range is very small. So we can say we will use 5 bins. So in 5 bins also you can distribute the data. And this is kernel density estimation. You can see where you have high peaks in kernel density, that means probability of finding values are more there. And you can see between 15 to 16, right? We have most students between the age 15 to 16, then 16 to 17 we have around 280, then 18 to 19 around 280. Then student in the age group of 19 to 20 are very very rare. Student the age of 21 to 22 are less than that. So kernel density estimation peak is also low there. So this curve is KDE. If you will use KDE is equal to false, this curve will not be visible. So if you want to display this kernel density estimation, you can use it, otherwise you can remove it. And we have a separate video for KDE also. So we have a playlist of pandas that will be very very helpful for you. And we also have multiple tutorials for Tableau, SQL programming, you know. So you can go through our different tutorials. Let me show you once again what tutorials we have. So here you can see uh, we have Tableau, we have Python, we have, you know, data analysis using pandas, PostgreSQL, machine learning. So you, if you want, you can check out these courses also. Now coming back to it, so here is a simple distribution plot where we are seeing distribution of age. Now we will use box plot. In box plot, we this is also used to see the distribution of data. So in box plot, we have a minimum value, a maximum value, and between the box plot, we have interquartile range. So these values that you are seeing here, like first quartile, second quartile, third quartile. So these values can be seen in a box plot. So here we are going to use data as a student. X is equal to gender, Y is equal to G3, palette is equal to cool warm. So here in X, we are selecting gender, and in Y, we are selecting the grade. So you can see the grades are mostly between 10 to uh, let's say 14, I will say. So they are between 10 to 14 for female, and grades are between 10 to, again, almost the same value for male. And but in case of male, you can see the higher range is in the range of 20. Okay, in case of female, the lowest value is in the range of let's say 3 or 4 here, right? And we have some, you can see outliers here also, people having 0 grade score. So this is our distribution, and here you can see the middle value here. So this middle line here is median, and you can read more about box and whisker plot on our uh, website. We have also created a description video. So this is the interquartile range. Here the box and whisker plot is just horizontally given. You can also see it in a vertical way. So you have minimum value, maximum value, representing minimum and maximum value of that particular variable. In our case, grade, lower quartile, medium, and upper quartile. Okay. If you will see our data.describe here, so you will see uh, in case of grade, right, G3, the median value is around 11.34, the mean value. But here you can see in case of male, this point, this line is on lower side, and here it is on almost the midway. So the median line in box plot represent the median value of G3 grades for each gender here. It tells us that 50% of the student in each gender score above the median grade, 50% score below the median grade. It shows the central tendency of the grade for each gender. Now, the important observation should be in a box plot, the median line always divides the data into equal halves. If the median is closer to the bottom of the box, right, in this case. So if the median is closer to the bottom of the box, the data is positively skewed, more low values. If the median is closer to the top, the data is negatively skewed, more high values. So in this box plot, the median is closer to the bottom, suggesting a right skewed distribution. More student scored higher than the lower grades. Okay, so that is what it is telling. So this is a simple distribution of box plot here. Then we will use the correlation matrix to see the correlation between different values. Okay, so student.corr will create a metric. In this metric there will be all. So first let me show you. So student.corr will be a matrix. So it's a correlation matrix, and it is saying you cannot convert float GP, right? Could not convert a string to float GP. So if this type of problem occurs, that means it is somehow encountering with a non-numerical value in the correlation. In correlation, all values should be numerical. So that's why to find the correlation matrix, we are selecting. So numeric student will be student.select data type and include np.number. This will only select numerical column, and correlation metric will work only with numerical columns. So you can see we have all the numerical columns like age, mother education, father education, travel time, study time. If you don't want to see it as a in a series kind of format, so you can always see it as a matrix. Obviously, we have many numerical values, and seeing them with all other numerical values will be a long task. But you can pause the video and see the relationship. For example, age with age will always be 1. Our important variables are grades, right? So here, for example, G3. So this is the G3. Now this value here is negative. So the negative value that we have here, let me reduce the size. So negative is age. That means when age is increasing, grade is decreasing. Mother education, positive 20. Positive 20 means that it is a probability that when mother education grade is increasing, then there is effect on grade also, which you saw in this example also, right? So that is the case. Father education also will have a positive effect. Negative effect means when that these two variables have a negative correlation. When one increases, the other will decrease, and the number here reflects the intensity of increase or decrease. Right? One means highest probability. Like for example, age versus age. Obviously, when age will increase, age will increase. So this is the correlation metric, and we can also see it in a graphical format. Or so in a student.heatmap, sns.heatmap, we will use numeric columns from a student table, and we are going to use the cool warm, and here you can see the metric. If you want, you can increase or decrease the size of this chart, but this way you can see a heat map. So to see it in a better way, you can see I have used plt.figure, fig size is equal to 19,4, and then you will be able to see a chart like this. Here it is easier to analyze. Red means higher value, blue means lower value, and all colors like orange means somewhat positive relation. So for example, G2 with G1, right? So in all the grades, we have a very strong positive correlation. Like if G1 will increase, G3 will increase. And similarly, for example, here, this is daily alcohol count and weekly alcohol count. So there is also a correlation. So this way you will be able to see, you know, correlation of different numerical values on other numerical values. And you will be able to figure out which values are important in order to predict the student grades on the basis of different features. So let's do the binary classification. So in data pre-processing, we will use student target. We are creating a new variable here called target, where if grade is greater than equal to 10, we will write 1, otherwise we will write 0. 1 means pass, 0 means fail. So np.where, we will use a simple condition. So this is like a switch case. If a student grade is greater than 10, then say pass, otherwise say fail. And this is going to create a new column here, right? So if you will see students dot head, you are going to see a new column here, that is target, with either 0 or 1. That totally depends upon G3 value here. Now we will create our input data and output data. So inputs will be, if we will drop G1, G2, G3 and target. So drop irrelevant or target columns. This will become our inputs. Input should always be a 2D data frame kind of thing. So it will be a 2D value, and output is a series or 1D value, right? So we are selecting the target as a Y value here. So now this will create our inputs and outputs. Next, we will use one hot encoding for categorical variables. So with the help of pd.getDummies from input, drop first is equal to true. Whatever categorical values are there, for example, in mother job, we have at home, health, other. In case of father job, we have teacher, other services. For example, these are father jobs: teacher, health, other services, at home. So obviously these cannot be given to machine learning model. So that's why we convert them in dummies. Okay. Dummies means, let me show you what it means. So when you will do this, then if you will print X, right? So you will see here. Now we have a lot of columns like guardian mother, true, false, guardian other, false, right? Let me select at home. So now in our inputs, see the columns, right? Health, absences, school MS, gender M, address U, fam size less than 3, right? So everything that you can see here is available here, right? So these are the column: mother job health, mother job other, mother job services, right? So if you will write X dot mother job services, you will see true false values here. Okay. So this kind of creates a dummy variable for us. And this type of value can be fed into a machine learning model. So always remember, before applying or before dividing the data set into testing and training, and before fitting the model with inputs and output, you have to convert them into dummies, and this is the shortest way of doing this. And drop first is equal to true, so it will drop the original column and create its different type of dummy variables, right? For example, job, teacher, health, other services. So you will see teacher, health, other services, right? So this way it will be converted. For example, gender is either male or female. So gender male, true or false, and female, there is no need for the other value here. Okay. So that's why in this case also at home is not needed, because if all others are false, then at home is equal to true, right? Now we have our inputs and the output. So we will simply divide the data set into training and testing part. So in train test is split, we will provide our input as the first argument, output as the second. We will say test size equal to zero point 0.3. That means 70% of the data will be used for training and 30% will be used for testing. And we provide some random state here. So this random state is basically for random selection of data. So out of 650 values, or out of 1000 values that we have, 700 random values will be given to training, 7 and 300 random will be given to testing. This is X train, X test, Y train, Y test. When you will run this, now let's see what is inside xtrain.head. So you will see all the inputs inside xtrain. Okay, you can see mother education, father education, travel time. These are numerical, and all other of them are dummy variables. Nursery, yes; true. Higher, yes; true. That kind of thing. Does a student have internet? Yes. If yes is false, that means he doesn't have. Romantic, yes. So you can see different type of values. Now after this, we have our values. Now we will import the model. So here I have provided the entire code also on my website. So from here, now we will import the model. So we will use random forest classifier. We will say random state is equal to 42, and we will use model.fit. So in first we are creating the model. The model is random forest classifier. It is going to create a number of trees, and in model we are going to fit the value, right? So here random forest classifier has now learned about the data from the training set. Okay, and now we will use ypred for prediction of values. So all the predicted value for all x test values will be stored in y prediction, right? So in x test we will have all around 30 columns there. So if you will see the shape, 39 columns, so all 39 columns will be fed, and 300 samples, or 314 samples, there will be 314 y predicted value, that is grade, right? Pass or fail. So we will simply create this, and now ypred, if you will print it, let's say ypred dot head, you will see top 5 values, pass or fail. So because it's a series, let's select. So you can see it's an array basically. It's not a series, but it's an array. So pass, 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 fail, fail, fail. These are 315 values. Now we will evaluate our model. For evaluation, we will use the confusion metric between y test and y predicted, the classification report that we imported between y test and y predicted, and the accuracy score between y test and y predicted. So you use these three classes, and you provide them y test, y predicted, y test, y predicted, and y test and y predicted. When we will run this, we will have them. The confusion matrix is 1663 and 16219. So this is, and similarly classification report tells precision 0 for 0.50, for 1.78. Recall is 0.20. I will explain you the meaning, but you can see accuracy score is around 74%. So in confusion matrix, you basically see true positive, true negative, false negative. That means correctly predicted positive cases, correctly predicted negative cases, incorrectly predicted positive cases, and incorrectly predicted negative cases when it's actually positive. So actual negative is 16 true negatives. These are predicted negative and predicted positive, right? Actual positive is 16 false negative, and 219 true positive. That is important here, right? So summary is the model performed well on recall, finding most actual positive values, but has moderate precision. Some false positives are also there. How to improve precision? We can reduce the false positive. We can enhance the model's performance. So the classification report we got provide detailed metric to evaluate the performance of your classification model for each class level. Here what this report means. So in the report we have precision, the proportion of correctly predicted instances for a class. So for example, precision 50%. Out of all student predicted to fail, only 50% were actual failures. So precision 50%, out of all predicted, only 50% were actual failures. Okay, here in zero case. In recall 20%, you can say The model only identified 20% of the actual failures. F1 scored 29%, a low overall performance for this class due to poor recall. So recall is poor. So here its accuracy is low for this class, 0 class. That means it is unable to predict the failed class properly. But in case of pass, the precision is 78%. Out of all students predicted to pass, 78% were correct. The model applied some algorithm there, and after applying that algorithm, it was able to predict 314 samples as pass or fail, whatever they were. So this is their accuracy. Recall here is 93%. Okay, the model successfully identified 93% of actual passes, and F1 score is 85, a good balance between precision and recall for this class. So this way you can see the effect of different type of inputs on your output. You can create a dummy you can create dummy variables from your inputs, and then you can provide them to your model, and then you can start predicting. Okay, so in random forest classifier, like whenever we are creating a model, you can also say number of estimators, like as per the diagram you can see number of estimators. Let's say we want is 50. Okay, so you can select that amount, and you can test for different number of estimators also, how well or unwell your model is performing. Obviously this is not needed, evaluation is needed. So here now you can see in 0 we have 52%, here it is same, right? So you have to see, and overall accuracy is now 75%. So number of estimators is something that you can use, and here we have different type of other parameters like random state 42 and so on. Random state will, if you will use the same random state, so same you know uh, obviously your model will select the same samples for evaluation. Number of estimators 550, 10, 20, you can use them with different conditions and see, right? So obviously let's say for 10 what is the score. So every time you can see the accuracy, and here obviously for class 1 is increase, class 0 is decrease. So this is how you can evaluate the performance of your model. And obviously we are going to create a lot more videos related to machine learning. This is just one example. We have many more examples for supervised and unsupervised learning on our channel, which is in the same playlist. Please go through them. Go through the initial videos first if anything is unclear to you at this moment. So when you will go through the initial values where we have explained about these different type of models, different type of algorithms, how they work, then you will understand it in a better way. I hope you understood the concept. Then in the next chapter, we will study something else. We will perform machine learning. We will create machine learning models, predict values, see their accuracy, do exploratory data analysis. Thanks for watching the video. Have a nice day.